From ancient rain dances to modern technology, humans have long sought to control the weather. One such innovation, artificial rain, offers a glimpse into our potential to influence the skies. But how do we coax rain from a cloudless sky? The answer lies in a fascinating blend of science and engineering known as cloud seeding. Artificial rain, also known as cloud seeding, is a weather modification technique. It aims to increase precipitation. This is done by introducing external substances into existing clouds. Imagine it as giving nature a helping hand to quench thirsty lands. The quest to manipulate rainfall has a long and fascinating history. Ancient civilizations attempted to appease rain deities through rituals and offerings. Today we turn to science. The concept of cloud seeding emerged in the 1940s. Vincent J. Schaefer, an American chemist, and Bernard Vonnegut, an atmospheric scientist, made groundbreaking discoveries. They found that silver iodide and dry ice could be used to create ice crystals in supercooled clouds. These discoveries led to the first cloud seeding experiments. Initial results were promising. However, the science behind cloud seeding was, and still is, complex. Debate continues regarding its effectiveness and long-term impacts. The potential benefits for drought-stricken regions and water resource management spurred further research and development. Cloud seeding might seem like magic, but it's a surprisingly straightforward process. It starts with identifying suitable clouds. Not all clouds are created equal. Only clouds containing supercooled water droplets are viable candidates. These clouds are typically found at higher altitudes. Once a suitable cloud is identified, the seeding process can begin. There are two primary methods: ground-based generators and aircraft. Ground-based generators release plumes of silver iodide into the atmosphere. These plumes are then carried upwards into the clouds by air currents. Aircraft, on the other hand, can deliver the seeding agent directly into the heart of the cloud. The science of silver linings. How cloud seeding works. The science behind cloud seeding lies in the microscopic interaction between water molecules and seeding agents. Silver iodide and dry ice serve as ice nuclei. Their structure mimics that of ice crystals. This similarity tricks supercooled water droplets in the cloud. These droplets, below freezing but still in liquid form, readily latch onto the seeding agents. This process triggers a chain reaction. As more and more water molecules freeze, the ice crystals grow larger and heavier. Eventually, they become too heavy to remain suspended in the cloud. Gravity takes over, and precipitation falls as rain or snow, depending on the temperature. The process essentially accelerates the natural precipitation cycle. Making it rain. Applications and examples of artificial precipitation. Cloud seeding has found applications in various parts of the world, addressing different needs. One of the most common applications is drought mitigation. In regions facing prolonged dry spells, cloud seeding can supplement dwindling water supplies. For example, China has invested heavily in cloud seeding programs, aiming to increase rainfall in arid regions and combat water scarcity. Beyond drought relief, cloud seeding serves other purposes. It can be used to enhance snowfall in mountainous areas, boosting snowpack for water resources and winter recreation. Additionally, it has been explored as a means to suppress hailstorms, protecting crops from damage. However, the effectiveness of these applications varies, and further research is needed to fine-tune the technology. Conclusion. A forecast for the future of weather control. As we delve deeper into the complexities of weather modification, ethical and environmental considerations come to the forefront. While the potential benefits of cloud seeding are undeniable, it is crucial to proceed with caution. Extensive research is needed to fully understand the long-term ecological impacts. We must ensure responsible and sustainable implementation. The future of weather control holds both promise and uncertainty. Advancements in technology, such as sophisticated computer modeling and targeted seeding techniques, offer exciting possibilities. Imagine a future where we can alleviate droughts, mitigate severe weather events, and ensure water security for all. However, it is paramount that we proceed with respect for the delicate balance of our planet's climate system. The ability to manipulate the skies comes with great responsibility, one that demands careful consideration and collaboration. If you like this video, don't forget to hit the like button and subscribe for more exciting content, updates, and new uploads from Manufactour straight to your feed.